I put on here when the Unit 1 and Unit 2 retests are going to be, you have 4 opportunities. It'll be the 20th and the 21st because drop deadline is the 22nd. 6 weeks eligibility check is the 22nd. So that's the systems test and the one that you'll take next week. The retest will be then. Said 8:30 or 12:45. If that doesn't work for you, you got to communicate that with me and we'll find a time. But that's just what I'm going to put right now because nobody ever comes after school. So I don't want to sit up here if no one's going to come. But again, if you're retesting, you'll have a potential to take 4. 2 from the first unit and then 2 from the second one. So I wanted to wait till then because you'll need some time after this unit too. But that's there. I put it on Canvas. So if you're planning on taking that, you can go ahead and like make a mental note there. And I'll have like sign-up sheets and stuff later. So the check for understanding that we just did, again, I'm going to go and it's just going to be right or wrong. So if you get a 25 in the grade book, it's not weighted. That means that you missed how many problems? 3, okay? So let that be kind of an eye-opener to, hey, I really need to pay attention next class when I pass that back and I go over the answers. The questions are good. The questions are really good. The questions are going to look familiar next week when you take the actual real deal. So you need to learn from that. I know I changed one of the problems that got some big numbers, but that's okay. You still need to be able to do those processes. So let this be kind of just a little, pre-test for you. And if we need to figure stuff out, then we need to figure stuff out between now and next Thursday, which is your Unit 2 test. What you just took aligns with topic number 1, okay? So you're going to have a test over those same ideas, functions, inverses, compositions, all that good stuff. Topic 2, we're starting today, and we'll finish up on Friday. It's just 2 lessons. We'll take a CFU for that, and we'll have a review day next week. Topic 2 is more about attributes. It's a lot less writing, a lot more interpreting, okay? So I don't know, that may be like really good for you or really not good for you. But you're going to be looking and doing a lot of writing, domain and range. We're going to talk about intervals of positive and negative, increase and decrease. There's more of that today as opposed to actually plugging in functions and doing computation. So it's a little bit of break from that, okay? Hey, do you have your notes back in? Okay, let's get it out. Okay, so what do we remember about domain and range? We're going to kind of have to speed through this first couple pages. But domain and range. I don't remember anything. I promise you learned it because I literally have taught it. Okay, good. Domain is left and right. So left to right is your domain. You are correct. Range. What did you say is range? Okay, it needs to go down to up, bottom to top, because it has to go in least to greatest order, okay? So when you write domain and range, this is what I keep saying in Algebra 1, you're just finding your boundaries. You're describing, hey, these are the X's that my situation is happening. My boundaries, my leftmost boundary, my rightmost boundary. My range, these are the situations, these are the Y's that my graph is happening. The bottom boundary and the top boundary. You wrote it, you can write it a couple different ways depending on if it's discrete or continuous. I believe everything we're going to be doing is continuous. So your setup, or at least how I literally taught it first period this morning, would look like this. With domain, you would probably write it as something is less than X is less than something. When I say something, you're going to have numbers in there. Okay, your boundaries, your left boundary and your right boundary. And what that means is between these 2 boundaries, between these 2 X values is where the graph is going on, where the situation is going on, the word problem, whatever you're doing there. And with range, you would do it, again, your boundaries, bottom boundary, less than Y, less than top boundary, okay? That's our inequality notation, because what's in that notation? Less than, greater than, inequalities. Okay, this is called inequality notation. This is how we teach it in Algebra 1. Inequality notation. Okay, I'm going to show you a shorthand today for this. And I will be picky in this unit about what notation. And I'm warning you right now. You're all here. Hear me out. Your test, I was just looking at it last period, is going to ask you sometimes to write an interval notation, sometimes to write an inequality notation. So be very careful about reading the problem to make sure you're doing the right one. So what we want to do is we want to figure out how to go from inequality to interval. So there's like some number lines and stuff here. There's a lot of words. There's just words everywhere. But this is what interval notation looks like. It basically takes out the less than's x less than y, and you really just talk about the numbers in terms of their boundaries. They're still in the same order. The left boundary will be first, the right boundary will be second, but they denote on if that value is included with a bracket or a parentheses. So do y'all remember in Algebra 1, and I'm going to guess maybe not, but when you had an open dot versus a closed dot? Do you remember what that meant? Yeah. Okay, good. Never what? Never learned them. Okay, someone help us. What does it mean?
Open dot, isn't it the or equal to? It'll be like greater than or equal to, or is it close?
You have it flipped. So an open dot is if you would just use a less than, because it wouldn't actually equal it there. A closed dot, you would use a less than or equal to. And that depends on your graph. When I say open dot, like you would have a graph and it would like literally have an open circle versus a closed, like endpoint would be a closed circle right there. In Algebra 1, I always say if they take the extra ink to color in the dot, take the extra ink to write the or equal to. So when you have to put your boundaries in, then you have to decide, okay, at this boundary, is my graph actually equaling that x value? Is it including it? If it's closed or if the graph is touching, then you would put an equal to. If it was a like definite open circle or an arrow, what does an arrow mean you're going towards? Infinity. We never equal infinity. So there are some times when you have that open notation versus not. In interval land, you denote that as or equal to, you use a square bracket right here. Closed brackets. Okay, so they look like that. So what we did is we said, let's look at this notation. -3 is less than or equal to x is less than or equal to 1. That's inequality notation because there's inequalities in there. If I want to take that to interval notation, I still have my same boundaries in the same order, least to greatest. But I get to drop all the less thans and drop the x's. And because I had or equal to, I use a square bracket here and a square bracket here. And then they put that on the number line just so you can kind of see what's going on the number line. So that's what it means to be a closed interval. That means those x values, or y values if you're talking about range, they actually are included on the graph. They will equal those values there. Open intervals are where you would have, again, open circles. It wouldn't actually land on the graph. It just gets really, really close. It would be just your straight up less thans. No equal to there. And when you use interval notation with that, you denote that by using a parentheses. So I want you to look at this versus this right here. And we got a little table because there's just these words. They're just stressing me out. Okay? So again, the numbers are still in the same place. These are your boundaries, -3 to +1. But because this guy right here has parentheses, I'm not actually equaling -3. I'm not actually equaling +1 because I just have parentheses. It's not an ordered pair. It's an interval, and you don't equal those values there. And then you can have like mixed matches. You can have one that has a closed and one that has an open like they do there. So in conclusion, open dots or not included points will use a parentheses and interval notation. Closed dots, I'm also going to put open dots and arrows, as in going to infinity. You won't equal that, so you use a parentheses. Closed dots, use a square bracket. I'm going to highlight this. Domain goes from left to right. Domain is always talking about your x's. Range goes from bottom to top. Okay, so we're going to do a little bit of comparison to the notations on the next page. I'm not going to do the whole chart because it's just a little bit redundant, but we'll just do a little bit to get you kind of warmed up to it, and then we'll jump into some examples. And again, hopefully this will be like, oh, I've seen this before. I just need to learn how to write it the new way. Okay, so look at the next page. Line number 1. I want you just to know, you've got to know the names of the notations. I'm going to tell you the ones that I really care about are inequality and interval notation. Okay, those are going to be the ones that I ask you. Set notation, let me just kind of explain what it means. It's, honestly, I never even used it until I was doing like number theory and stuff in college, but it can be on there. They put on the STAR test like a few years ago, and I was like, what? But it's not really that different. But set notation, what it means is they kind of start with those set, like when we were writing 3 variable systems and we use the squiggly brackets, that's a set. So do you see how it says squiggly bracket X and then a line like that? Do you see what I'm looking at? Okay. You read that as X values such that, that's what the line means. Okay. Just that line means such that -3 is less than X is less than 5. Less than or equal to X. Less than 5. So all the difference between inequality and set notation is kind of that extra little squiggle on the front. X such that. It's not that important for what we're going to do, but if you see it on the SAT, just kind of pay attention to this guy. This is really what where your boundaries are going to be. Okay, so no stress about that. So, but we're really harping on inequality versus interval. So they filled out the first 2 for you. Based on their number line there. Again, they had a closed circle at 3, so they included that less than or equal to there. They did a square bracket around -3 there because it was closed. 5 was open, so they just did a less than. They just did a parentheses, good to go. Okay? This one on number 2, this one's already completed for you. This one has an arrow, so that means it's going on forever. So for the inequality, and it's open, they just said that X is greater than 2. Well, they said greater than because which way was it going? To the right.
To the right. Yeah.
Right is greater, okay? And so there's the set, and then if you're putting that in an interval notation, right forever is positive infinity. So let's just try, you guys try 3, 4, and 5. And then we'll move on to the next page. Okay? So try to fill that out based off of what you know. I'm going to kind of start working the first one if you're like totally lost. Order matters on this one. So I put the number line first, actually, before I went to the interval, because this interval is a little bit tricky. Where's your left boundary on this one? Which infinity? Negative. So when you write this interval, and this is something that gets people, you have to write least to greatest. Negative infinity will always be the least. So negative infinity up until, where's our upper boundary? +3. And a square bracket around that because it was equal to. Okay? So that one had an arrow. I can go from there. So try, do y'all know the ors?
No.
Do y'all know number? Because it's going left forever. Left forever is infinity, but if it's going in the positive direction, it'll be positive. Negative direction is negative. Y'all don't know the ors? Okay, so let's put our number line. At 1, are we going to put it open or closed? Open. No equal to. And which way is our line going to point? We want x values less than 1. So we need to point to the left. Y'all are going to have to do this when we solve absolute value in a few weeks. My other boundary is at?
X is greater than or equal to 5.
So I'm going to put a closed circle at 5 because it's greater than or equal to. And this one points to the right. Okay? So I have 2 different inequalities. I have 2 different little pieces of my number line. I'll do the set for you. X such that x less than 1 or x is greater than or equal to 5. So if I have 2 inequalities, 2 pieces on the number line, how many intervals do I need to have? 2. Okay, and you're going to see this today. So it is possible to write 2 intervals. So let's do this interval first. It's got an arrow going to the left. Left forever is what boundary? Negative infinity. Okay? All the way, goes, all the way until it gets to what value? +1. Is it equal at 1?
No.
How do you know?
Open circle.
Open circle, also right there. So you close it off with a parentheses. Okay? I am going to be grading parentheses and brackets, so you better be getting them right. Now, when you have multiple intervals, you're going to separate each interval by a union symbol. It's just this little U. There's a button on Delta Math that you need to press. Don't use capital U because Delta Math sometimes counts it wrong. That means or. So this is saying, hey, our numbers can be in this interval or the other interval, which I'm out of room. But what's this other interval going to be? Where does it start? 5. It's included, so I got to put a square bracket. And then 5 has an arrow pointing to the right. Right forever is positive infinity. We never equal infinity. Put a parentheses there. So if you have two inequalities, you're going to have two intervals like that. Okay? How many intervals should you have on number 5? How many things are in your number line?
1.
Just 1. Okay? And it will go from open circles. What's your numbers?
-5.
-1. And then as an inequality, x is greater than -5 and less than -1. You can read it as -5 less than x less than -1, but that's what it means it works. And then I'm going to just skip out on the set notation. Okay, so this is just honestly practicing between the notations, looking a little bit at a number line. I'm not going to be testing you on that. What I am going to be testing you on is going to be on the next page. So are we okay if we skip the last two? Yes? Okay. Next page. Domain and range of graphs. You will see this on your test. So star this page. Good times. We love domain and range. Again, pay attention. Pay close attention to the notation. Because I promise you, I'm going to be picky about it on this test. After we get through this test, I don't really care about the notation. I just want the right answers. But I need to make sure you know both. And so that's what this test is going to be about. So let's do number 8 together. And I'm going to have you guys try number 9. And then we might talk about 10 together because there's arrows, okay? So the first side, I'm going to be doing inequality notation. I always kind of do my little setup like this. Less than, what goes in the middle with domain? What variable? X, less than. With range, it's less than, Y, less than. You get those backwards, you're getting points off, so don't. That's the easy part, okay? And then I think it's helpful, or at least this is how we do it in Algebra 1, because whatever helps, is I always actually highlight on my graph, I draw in my boundaries. If you don't need to do that, that's okay too. But I'm going to go and I'm going to put my leftmost x value, because I'm doing domain first, and what x value is our left boundary? This is a terrible picture. -4, and it's a closed circle, right? So I'm going to put a less than or equal to x. And then what about my right boundary?
Open.
It's open, so I'm not going to put an or equal to, but what x value is that at? +4. Okay? Let's take that to interval notation real quick. How do you switch? You take out that middle chunk, and you have to use brackets and parentheses. So the numbers will go in order. -4, comma, +4. But what am I going to put around the -4? Because it was closed. Square bracket. What am I going to put around the +4? Because it was open. Parentheses. You see how this one is so much faster? Way faster. Okay, it's a really, really good shortcut. But I'm going to make you do both in this. And then after that, if you want to use interval notation all year, that's good for me too. Range. Lowest y value. It is. Left to right. Well, the lines are up and down, but I'm just looking at the x value. -2. Well, I think it's -2. Because the lowest. And then equal to. What is the highest?
2.
And it's open. So leave it there. So there's your inequality. How do you write that as an interval?
You have the bracket and then -2,
-2, comma 2. Have y'all seen interval notation at all?
No.
No? Yes? No? Okay. All right. Try number 9. Is number 9 a function?
No.
No, why not?
X repeats.
Fails the vertical line test. X repeats. Yes, but you can still do domain and range even if it's not a function. So, ready, set, go. Do that one. Yes. Like open or close circles on this graph. No. So if there's not a defined open or closed circle, we are going to assume for now, we're going to assume that it is equal. The graph actually touches it, takes that value. So for these guys, you should be doing equal to's for all of them. There are cases when it may not necessarily get there, but we'll do that later in the year. Hey, y'all, so here are mistakes that, listen to me, check this one up here, and then we're going to talk about the arrows, because you're going to see arrows. Here are mistakes that people make for this. First thing is either not putting an equal to or a square bracket when you should, or vice versa. So you've got to know open circles and arrows should be round parentheses or not equal to. Closed circles or graph is touching, then you put the line or not. The other thing is, and I don't know, it's usually, domain is usually right, but it's with the range. The way that you write the numbers, the first number always has to be smaller, least to greatest. So if you don't do it like just, oh, I'm going to just bound it off and write whatever order I want, it's got to be least to greatest, bottom to top. It really comes into effect on a problem like this when you've got negative infinities. So I'm warning you, you've got to always be thinking least to greatest. So let's look at number 10, okay? We have a graph here. There are arrows. The arrows are going to make things a little bit different. So inequality notation. Actually, let's do interval notation first for fun, okay? Do I have, I'm talking about the domain, so I'm looking at the x's. Do I have a left boundary that I can put on this graph because of this arrow? No. So I don't have a boundary. What number represents left forever? Negative infinity. That has to go first. Will we equal negative infinity? So I have to use a parentheses, negative infinity. Okay? Do I have a right boundary? No. It's going right forever. I don't care that it's pointing down. It's going right forever. Where is that going to? Positive infinity. Close it off. So what does that look like in inequality notation? Correct, but if this actual notation right here is, if it asks for inequality notation, you need to use the inequalities. But I do want to point that out. Shh. Quit talking over me. If you have intervals or inequalities involving negative infinity to positive infinity, after this test, I'm totally fine if y'all write that as all real numbers. But if I'm asking for the specific notation, I need that. Do y'all know what that means? All real numbers? All of them. No stopping points. No boundaries. Do y'all know what the symbol is for all real numbers? Line, capital R. If you don't know that, write it down because it's going to make your life way easier later. Okay? So if your graph has, that means all real numbers. It's math language. Math is its own language, people. Vertical line means such that. This means all real numbers, okay? If you have left and right arrows, and a lot of our functions, our domains are all real numbers. Lots of them. Because they go from negative infinity to positive infinity. A lot of them have ranges that are all real numbers as well. This one doesn't. Interval notation first. Do you have a bottom boundary? No. What is your bottom interval? Negative infinity. Do you have a top boundary? Yes. What's your top boundary? 2. And there's no circles on 2, so we're going to assume that it equals, so I put a square bracket. Okay? This is a good problem. I would star this. And then my inequality would be negative infinity less than y less than or equal to positive 2. Okay? So you are going to have some questions that are going to ask about domain and range on your test. You are going to be asked for a specific notation, and you must use that specific notation, and you must use it correctly. So we will practice that. I think this is in Delta Math, pretty sure, but I know it's on your test review as well. Okay, this should have been a little bit of review. The interval notation is new, but writing domain and range should be reviewed. The next part is going to be kind of new. Again, flip over. There's lots of words. I've got a video that we're going to watch real quick, but I just kind of want to tell you we're still going to be classifying, okay? We're going to talk about big picture, domain, and range. But then we're also going to look at these functions and give more specific domains, and those are going to have to do with like positive and negative intervals and then increasing and decreasing intervals. It's not very complicated to do, but for some reason, it just like sometimes blows people's minds. So watch this video, follow along. I'm probably going to be pausing it. I think it's going to have you draw a picture in this space. And then again, if you have highlighters, I like highlighters here, and I might stop the video as he's talking.
Positive. Well, positive means that the value of the function is greater than 0. It means that the value of the function means that the function is sitting above the x-axis. So it's sitting above the x-axis in this place right over here.
This is what I'm going to be highlighting.
And it is
Oh my God.
also sitting above the x-axis over here. And if we wanted to...
So what we're going to be doing is I'm going to be asking you like these different questions. Where is your graph positive? Okay, and you're going to be writing little like miniature domains of, hey, it's positive in this little domain. It's also positive in this little domain. The thing that's a little bit different about this is everything with positive, negative, increasing, and decreasing is always in terms of x. That's why I call them miniature domains. I don't want you writing down anything about the y's, but sometimes you have to look at the y's behavior, okay?
We wanted to write those intervals mathematically. Let's see. Let's say that this point right over here is x equals a. Let's say that this right over here is x equals b, and this right over here is x equals c. Then it's positive. It's positive as long as x is between a and b. At x equals a or at x equals b, the value of our function is 0, but it's positive when x is between a and b, or if x is greater than c. X is, we could write it there, c is less than x, or we could write that x is greater than c. These are the intervals when our function is positive. Let me write this. F of x positive when x is in this interval or this interval or that interval. So when is f of x negative? Just another color. F of x is going to be negative. Well, it's going to be negative if x is less than a. So this is if x is less than a. Or if x is between b and c, then we see that f of x is below the x-axis. F of x is down here. So this is where it's negative. So here, or x is between b or c. X is between b and c. And I'm not saying less than or equal to, because if at b or c, the value of the function, f of b is 0, f of c is 0. That's where we are actually intersecting the x-axis. So that was reasonably straight.
Okay, so positive and negative. So it's basically saying where are you, again, you're looking at the behavior of the y's, but you're writing it in terms of x's. So where are the y's positive? Where are the y's negative? It can mean that it's multiple places, okay? It may be just that there's one place. It just depends on the picture that you have. But did you hear how he was saying that we don't equal 2 in this? Why do we not equal?
0.
Because is 0 positive or negative? No. So you won't equal 2 if it just says positive. I'm going to put a little side note in here. Delta Math, our good old friend, Delta Math sometimes actually does say like greater than or equal to 0. So there may be cases only in Delta Math that you might have to put a square bracket, but y'all will see that when you get there. And I'll show you what it looks like on paper. But typically what I'm going to be asking you is just for positive and negative, which just means use parentheses on all those, okay? But write it in terms of x's. I think next is going to talk about increase, decrease.
Forward. Now let's ask ourselves a different question. When is the function increasing or decreasing? So when is f of x in increasing? Well, increasing, one way to think about it is for every time that x is increasing, then y should be increasing. Or another way to think about it, you have a positive rate of change of y with respect to x. You can even think about it as, imagine if you had a tangent line at any of these points. If you had a tangent line at any of these points, the slope of that tangent line is going to be positive. But the easiest way for me to think about it is, as you increase x, you're going to be increasing y. So where is the function increasing? Well, I'm doing it in blue. It's increasing right until we get to this point right over here, right until we get to that point over there. And then it starts decreasing until we get to this point right over here, and then it starts increasing again. It starts.
So increasing is when you're talking about, you read a graph left to right. Where is the graph going up?
Let me make some more.
That's all it
here.
means.
So let's say that this is x equals d, and then this right over here, actually do that green color. So let's say this is x equals d. Now it's not a, d, b, but you get the picture. Now let's say that this is x is equal to, let me do it a little bit, x is equal to e. X is equal to e. So when is this function increasing? Well, it's increasing if x is less than d. X is less than d. And I'm not going to say less than or equal to, because right at x equals d, it looks like, just for that moment, the slope of the tangent line looks like it would be constant. We're going from increasing to decreasing. So right at d, we're neither increasing or decreasing. But then we're also increasing. So if x is less than d, or x is greater than e, or x is greater than e. And where is f of x decreasing? So f of x, this is a different color. When is, let me pick a mauve. So f of x decreasing, well, it's going to be right over here. It's going to be right between d and e, between x equals d and x equals e, but not exactly at those points, because at both of those points, you're neither increasing nor decreasing. But you see right over here, as x increases, as you increase your x, what's happening to your y? If you go from this point and you increase your x, what happens to your y? Your y has decreased. You increase your x, your y has decreased. You increase your x, y has decreased. Increase x, y has decreased, all the way until this point over here. So f of x is decreasing for x between d and e.
Okay, so we'll stop with that, and I'll talk from here. I hope I'm not as annoying as his voice is in teaching, or like repeating himself all the time. So hopefully I'm better than that. But I just like the visual of it, and this is essentially what we're doing. Is we're gonna read a graph and we're gonna interpret, and we're gonna list these places as intervals of x. And he did all inequality notation over here. We're good to use interval notation because it just is going to take less writing, I think. But the big deal is I want you to be able to understand like what it means when I ask where is it positive, where is it negative, where is it increase, where is it decrease. So he kind of gave a little more formal definitions, and if we go back to your notes, we've kind of got it written down here. But I'll kind of give you the moral of the story is a graph is positive where the function is above the x-axis. That's what we want to know. It's positive when it's above the x-axis, okay? That means the y values are positive. Again, delta math, they're just a little bit... Delta math is a little bit picky, and they will say where is f of x greater than or equal to 0, and that means you're going to need to actually include that x-intercept there, but most of the time we'll use parentheses. So if you get that, we'll talk about it. It's negative where the function is below the x-axis. So that's just saying, hey, like where are the y values negative? That's all that means. I always make a note about this. When you're talking about positives and negatives, did you notice on the graph where he always stopped with positive and negatives? A, B, and C. What attribute are those? Yeah. What would you say that is on a graph? Points A, B, y equals 0. What is it? The point where y equals 0, what's its name? What is it intercepting? The x. That's your x-axis, or x-intercepts. So those stopping points for when your graph changes from positive and negatives are at the x-intercepts. What are the other names for those? No, x-intercepts. There's 4 names for those. Yeah, 4. Don't ask me why. We can't just stick with one. X-intercepts. Roots. Does that mean anything? Please tell me you learned them. Oh, dearest. Okay, x-intercepts, roots, zeros, solutions. Okay, all of those mean the same thing. But that's kind of like anytime you're doing positive and negative, those x-intercepts, zeros, root, solutions, those are going to be your stopping points. Okay, so kind of keep that in mind. You're looking for stopping points there. Increase and decrease, again, he gave a whole definition about slope of a tangent line and yada, yada, yada. Okay, here's the thing, is going up. If it's going up, it's increasing. If it's going down, it's decreasing. You have to make sure that you're reading your graph, though, from left to right. So, like, follow your graph. If you're going up, we're increasing. If you're going down, you're decreasing. Increasing, decreasing, yada, yada, yada. Okay? Those points that you're going to change at, I'll go back to his. He added those in, D and E. Those are going to happen wherever you have a maximum or a minimum in your graph. So you're going to grab those x values that your concavity is changing. They're called extrema, maximums and minimums. So those will be the changing points for where you have stopping on your interval. So I'll say stop at your maxes or mins. Okay? So that was just kind of an explanation as to like what's actually like what you're looking for. Now, it's not hard to say what we're looking for. Now we need to like put it in action and actually like find some graphs, find some intervals, and go from there. Okay? Ready to try some? Yes, that's not bad. It's not bad. Yeah. Most of the time, yes. But I was saying that this is going to be in Delta Math. So like fair warning, you would put a bracket. Okay? Make note. With increase and decrease, always use parentheses with increase and decrease. And honestly, you can probably say the same for positive and negative, unless you're in Delta Math. And the reason why is because when you have that concavity change, when you switch from increase to decrease, at that exact point that happens, the function's not doing like both. So we won't use square brackets when we do these intervals. So like just make that be easy for you. You're just going to use parentheses with that. So here's just some more diagrams like showing you like positive and versus negative. One thing that wasn't in his video that you will see is right here, constant. Okay, constant means you're not changing your y's at all. You're just like straight horizontal. So he didn't talk about that, but you can still give an interval for that. And so we'll practice that here. Okay? All right, so let's just do some examples. And then I'll let you practice, okay? Because it's going to take practice with this. So given the graph of f of x here, it's nice, pretty parabola. Remember, this is what's coming, is quadratics. It's going to be a fun time. What intervals is f of x increasing? So let's answer that one first. Where are we increasing? How many intervals is our graph going to be increasing? 1. Can you highlight or draw on your graph where it is increasing? Left to right, people. Am I increasing at the beginning or at the end? At the beginning. I am increasing all the way up to here at this little maximum. Okay? I highlighted that in green. Now I need to write an interval for that little green branch. Intervals are going to be written in terms of x. So, where am I increasing from? Left forever. What is left forever? Negative infinity. And I am increasing until I get to what x value? 0. Okay, notice, it may be hard to tell, but I went to this maximum up here. I took my line all the way down because I need that x value. 4 is not going to be a part of the answer. It's x value to x value. And I will use a parentheses because 0 is where it changes. I'm not going to use brackets ever on increase and decrease. Okay? So that was increase. What about positive? Where is my graph positive? Just the top. How many intervals is that going to be? 1 or 2? Why does it have to be 2?
I think
It's
negative 2 and positive 2.
Correct. So you have 2x intercepts, but there's only one little chunk that is above the x-axis. So again, think about your stopping points. Even though it changes concavity, they're still positive, so I don't have to stop when I have that little maximum there. So I want to talk about the roots, which you are right, and there are 2 of them. Where does it start being positive? Negative 2. Now it's just asking for positive, which would mean f of x is just greater than 0. I'm just going to use this notation because this is what Delta Math does. 0 is not positive, so I'm using parentheses. Negative 2 is where it starts being positive. It turns around, but it stays positive until where? Positive 2, parentheses. Okay, that's this one. Delta Math, just to prepare you. Delta Math would say, could say, greater than or equal to 0. Do y'all see the difference in this and this?
What is DM?
Delta Math. Delta Math. This is just if you see it, because I just want to avoid getting the same question 800 times. Okay? So Delta Math may ask you, where is it actually greater than or equal to 0? What's the only thing you got to change?
The bracket.
You just put a bracket with that, negative 2 to positive 2. I will ask you this way. This is just a Delta Math thing, and I can't change it, and I don't, whatever. Okay, it's good to know the difference between the 2, but that's what it will be like there. Okay? All right, 12. We okay with 11? All right, 12. Where is the graph decreasing? Let's do that one first. How many places is it decreasing? 2. All right, let's highlight them. Again, left to right. So I start decreasing, then I switch, increase for a minute, then I switch, decrease for a minute. So those 2 areas right there. I'm writing that interval in terms of x's. Now, there's 2 highlights. Means there's 2 intervals. Means I'm writing 2 things separated with that union sign. All right? Start decreasing from where? Negative infinity until what x value? It's the x value that I care about. Negative 3. Always use the parentheses. Union. That means here's the other one. Or, what interval is this guy? 0 to 3. Those are the intervals that I'm decreasing. What about positive? This one's a little tricky. Okay, I just said positive. I didn't say greater than or equal to 0. So what's going on right here and right here? When I'm at 0, those are stopping points. Those are stopping points. So I have to write an interval for this, an interval for this, and an interval for this. To write 3 intervals because it just asks for positive. So at these 2 x-intercept, 0's root solutions, the graph is not positive because it's at 0. So I have to stop there. So that would be negative infinity to negative 3, union, negative 3 to positive 3, root to root, union, 3 to infinity. And I always write these, again, I'm always going left to right. Always going least to greatest. I think that's just easier there. Okay? Try 13. Hang on. Did you finish this page? I'm almost done. Constant. You need to know constant. I highlighted it. Okay? Shh. Again, they're in terms of x's. Just always use parentheses on these to make it easier for yourself, except for Delta Math. Okay? All right, and that's only on like one type of problem. What x value do we start being constant? 0, and then we continue just straight across until we get to 3. Y'all see how I'm like drawing lines to the x-axis? Like draw over this picture, okay? If you need to, if that helps you. That's not the only place that it's constant, so I'm going to put union. On Delta Math, y'all need to press the union button. Do not use a capital U. It'll count it wrong. Then I start being constant again from what x value? 6, and then it goes on forever, so that would be positive infinity. Okay? The next thing it asks is negative. How many places is it negative? 2. This little piece is below the x-axis, and that guy is below the x-axis. So how do you write this one, left to right? Negative infinity all the way until your root at -2. Close, because it just says negative, not equal to. Then it starts being negative again at what x value? Until it actually stays negative forever. Because it's still, even though it switches from decreasing to constant, it's still, yes. Hey, they may have a question that you have. You're confused as to what?
I'm confused on why 0 wouldn't be like why you wouldn't put the square bracket.
Some textbooks say that you can.
No, but like for the constant one.
Right, and well, we said 0 is not positive or negative.
Yeah.
But when it's changing from like one direction to the other or one direction just over, I always just say don't include it. Again, some textbooks are like always include it. It kind of depends. But for simplicity, I'm just going to say just use parentheses. Was that your question too? Did you have a question too? Was that it? Yeah, and I might differ. I'm pretty sure all the Wakeland teachers are on the same page about that, but some are not. Or other schools might be different. Yeah.
So like even if that's even if it's a straight line, right?
Yeah, I increase, decrease, constant. Just always use it.
Because after it's positive, right? That's when it's changing. -2 is when it's changing.
Just so aggressive.
Correct. It crosses the x-axis. Okay. All right. Here's one more. There is some Delta Math. You can do that without a calculator. I'm gonna do this one because it's got everything, and I think this one also has arrows, which might be worth noting here that there's arrows right there because that's a little bit different.
That's
So.
infinity.
In negative infinity. So I'm going to do that one. But then I don't know how much Delta Math. There's not a lot, I don't think. 3 or 4. Okay. All right. That's fine. You may need a brain break from it.